So for today, you will be doing lab module number 3. Okay. So the title is still PIC input and output, but you're going to concentrate a bit. We're going to focus more on 7 segment and keypad. So basically, you have learned introduction, briefing, interfacing, programming, and so on, related to 7 segment. And then the keypad, you will continue next week. Yeah? So for today, just a brief explanation regarding related to 7 segment. And then I will try to uh, give proper explanation because this one will be covered on Monday. So I will try to give you understandable explanation. So there are two objectives. The first one and the second one, same. Write a C language program, but for number one, you need to write a C language program to control 7 segment using PIC 16F877A. And then the second one, also the same, write a C language, but this one with the introduction of keypad. Introduction of keypad, and then from there you try to write a C language program to control and manipulate what happened to the output when the input parameter changes. So you need to do that. There are 2 items here. And then after that, the component require still the same, similar like the previous one, MPLAB, XIDE, XC8, computer unit, and then the last one, PixSimLab, the simulation software. So we look at the introduction first, just a brief introduction. If you want to know more, you can refer to the lecture note. So basically, we know there are 2 types of 7 segment, CAD and CCD, common anode and then common cathode. So we use the 7 segment to display mostly for numerical, but for the alphabet representation, very limited. Yes, maybe from A to F. Other than that, would be impossible by using a conventional 7 segment. So basically, most of the application related to the displaying of numerical digit ranging from 0 to 9. There are 2 type configuration, CA and CC. So when you are dealing with these 2 type, the activation code, you must properly adjust so that it will suit either one. Okay. For CA, it is common anode. So basically for CA, okay. So the CA, in order to activate the 7 segment for CA, you need to provide logic 0 or lower. And then for CC, common cathode, in order to activate a certain specific segment, you need to give high or 5 volt to the 7 segment. The data input must be connected to pin A, B, C, and up to G. So when we count this together, starting from A, B, so on up to G, there will be 7 pin or 7 bit, excluding the DP, decimal point. So basically, throughout the rest of this lab session, we will not consider programming with the introduction of digital decimal point. So all the programming question scope only relate to displaying the number character. So basically, as you know, we can either connect directly to the microcontroller or we can use the decoder, special dedicated decoder, CD4511. So, but before that, you refer first to table 3.1. So this is the truth table. According to the configuration, the first one CC, second one CA. So for CC, in order to display certain digit starting from 0 up to F, these are the code that you need to give to the input starting from A to G. So we just ignore the DP, and then same goes for the other one, CA, but the activation code is opposite from the CC. If you're giving 1 to CC, so this means that you need to give 0 for CA. Opposite value activated activation logic for CA must be 0, for CC must be 1. Okay, so this one will give out digit 0, same goes for this one. Okay, so the order is shown here. Okay, so you can choose which type you want to display, which number, which character, according to the arrangement here. And then if you refer to figure 3.1, this is the connection. Okay, so basically, what you have here is a decoder. We have two decoder, two IC decoder, CD4511. So we use it to connect to the 7 segment. Okay, so the connection you can see here, okay, the starting from A, B, C, D, E up to G. So this one go to the specific segment per 7 segment per item. Okay, so this one for this one, and then the other one, okay, for this one. Okay, so the arrangement is according to what you have seen in your module. And this one will be output from the microcontroller. So you can see from here, output connected to port D, starting from RD0 up to RD3. Same goes for the bottom, RD0, RD3. So this means that the PIC is sharing okay, the bit share same output between here and here. So what if you want to choose either one? So basically we use this pin, okay, RE0 and RE1. We want to select which segment that need to turn on, either one or both. Okay, so you can do that through these two pin here, the select pin, which connected to the LE. We call it latch enable. And then if you refer to figure 3.2, okay, this is the logic value that you need to give through port D, only for bit. Only for bit starting from D0 to D3. This one, since we are consider starting from 0 to 9, so the rest, so you can see the rest, okay, we just ignore. Okay, so in between 0 to 9, so you can see the value remain unchanged, okay, throughout from 0 to 9. So basically, this one you can either connect to ground or to the source VDD. Okay, but for this one, you need to connect to port D, starting from D0, D1, D2, D3, okay, because this one will give output to this decoder, and then this is the output. Make sure that you connect correctly. Pin A, output from the decoder here go to pin A, B, and so on. Okay, and then that one will enable certain character. So basically, for today's lab, you not compulsory. You can either use this kind of method, this kind of connection, or direct connection between PIC microcontroller and the 7 segment. So you can choose either one. Okay, but for this one, it is required to inform you that this type of connection is available in your PTK40A, the kit that you will be using during the hardware session. So when you come back after the second semester break, okay, and then you do the hardware lab, okay, so this is the connection that you use. Okay, so make sure that you can familiar with the changes. Okay, but for today's lab, you can use either one. Either you can connect directly between PIC and 7 segment, or you can use this type of connection. So we go to this one, already known. So these are the type of connection. Why we call it CC, why we call it CA. And then, okay, so we go to the keypad interfacing. Okay, so since there are no question, Okay, we go to keypad interfacing. So what you see in figure 3.4 is a structure of 4 by 4 matrix keypad. Why 4 by 4? So we have 4 column and then 4 row. So that's why we call it 4 by 4. And then you can see the internal structure normally consists of multiple number of switch or press button, press button. So basically the keypad construction normally mainly consists of push button. So the push button numbers you can see here from switch 1 up to 16. So total up to all the switches here is 16. And the number here is very significant. Okay. Switch 1, switch 2, switch 3. That one you will see later on during the program. Okay. So right now you need to be aware of this number also. Okay. 16, 12, 11, 10 and so on. Okay, so this is the internal structure. So what about the outer structure? So for those, okay, this one just for your experience only. So this is what a typical keypad normally looks like. Okay, so this is 4 by 4. So you can see a combination between number and also alphabet, and also we have two special character, star and also a hash. So we go back to the introduction. So basically, if you refer to figure 3.4, if you look at this point here, okay, for the column 1, call 1, call 2, call 3, call 4, column, it is actually column. So this means that you need to connect this one to the available pin from your microcontroller, directly connected to the microcontroller. This one, also this one. So total up will be 4 plus 4 should be 8. So make sure that you need to identify 8 bit of free pin in your microcontroller. Okay, so the arrangement can be anything. It can be combination between port B, port C, port D, port A, and so on. Okay, but better for beginner level, try to accommodate, try to allocate the whole port okay, for the keypad. Let's say if you want to connect directly to, maybe you can connect directly to port D. So you reserve the whole bit for port D to connect for the keypad, starting from column 1, column 4, and then you follow from 1 to 4. So how do we connect? So you can see for figure 3.5, this is how you connect to the PIC microcontroller. So the arrangement, so you can see from here, the default mode is port B, port B. You can also use combination, different combination. Port, this one might be port D, this one might be port B, okay, this one might be port A, and so on. Okay. So, but if you are in the level, in the beginner level, so better follow this kind of setting because it will be easy for you. So you can see here, we start by port B. Okay, so port B will be connected to row, and then the remaining, okay, the first 4 bit, starting from bit 0 to bit 3, this one will be connected to the keypad, okay, to row section, okay, to the rows. And then the setting must be set as output. So this means that you need to set trace B, B0, B1, B2, and B3 as output. So what is the value? You need to write 0 to trace. So you need to write 0. This one, the first 4 bit here, not similar, okay, but only the last, okay, the last one. Make sure that 4 bit, 8 bit total. So for port B0 and B3, this is the value that you need to set. And then the remaining would be here, from here to here. Okay. Also for bit, so this one you need to set as input. So this one you need to change to 1. Okay, because this one starting from bit number 4 to bit number 7. This one from bit 0 to bit 3, 0, 1, 2, 3, and then the remaining one 4, 5, 6, 7. So this one you need to connect uh, to the input. So the arrangement, you can also use this kind of arrangement. You can also use more than one port, but make sure that the setting is correct. So we move on to the figure 3.5. We go to the 3.6. And then this is what you see. Okay, so the schematic layout. So basically, RB0, RB1, RB2, RB3 set as output. This one set as output. Okay, this one set as output. This one you need to set as input. Okay. KC here will be the column. Okay, column here input. And then this one set output at port B. So how does the algorithm function? So basically the process that detect the character when being pressed. So we call it scanning method. We call it scanning method. So what does this process do is that it will scan row by row. So if you refer to figure 3.5, the program will start scanning starting from row 1, and then after that it will jump to row 2, and then jump to row 3, and then jump to row 4. And then it will repeat again. So when row 1 is being detected, so if you are pressing, if the user is pressing either 4, okay, maybe 1, maybe 2, maybe 3, maybe 4, so it will return the value. Okay, so let's, for example, column 3. Right now the column 1 is activate, and then at the same time the user is pressing column 3, so it will detect the number here. Okay, so like I said, why not 3 the number? Because number here. Okay, so it is actually giving out, returning the number here, not the value of the character. Okay, let's say if the user press A, it will not return A. Okay, it will return the number, the index number. Okay, so the index number here is 0, 1, 2, 3. Okay, so the index number here is 3. Okay, so that one we check. Okay, so you can refer this on the program side. Okay, so later we will explain. I will explain. So you can see here. Okay, so start with number 1. Okay, the index number start with number 1. So the return number should be number 4. Okay, so the return number should be this one. Okay, if the user press A, the character A will not be returned to the program. Instead, the number 4 will be passed to the program. So then the program will decide what to do. So that will be the scanning process. So the program will scan. So scan one by one, and then we refer again to this figure. Okay, so right now, row 1 is being activated for scanning, and then after that, it will the process will jump to the following row number 2. If no keypad, okay, so there will be no changes. Okay, according to the character, and then the whole process will repeat again. And I have prepared a very short explanation. Okay, so hopefully this one will give you proper understanding. Tak ada, not available lah. Sorry ya. That one I will show you later lah. Okay, but okay. Might be somewhere around here. Okay, so listen carefully ya. Okay, so very short. Hopefully you can understand. Do you have any question? Ada soalan? Okay, no question. So no question. We look at exercise number 1. Exercise, for example, number 1. This one very basic only, just brief. Connection, just a connection to the 7 segment and then just to display. So the connection shown in figure 3.7. So the microcontroller connected to 2 7 segment display program. So we call it this one display program, and then the question is write the following sample program to count out from 0 to 9 on the 7 segment. Only 0 to 9. And then the counter will increment when switch 1 is pressed. So basically one input. What happen if you press switch 1, the number here will start rising from 0 to 1, 3, 4, up to 9. So the program code here, what you can see here, you start by representing RB0 at by SW1. So this one we call it switch 1. And then the other two, the selection. The selection bit for segment 1, 7 segment 1 and 7 segment 2, we call it seg 1 and seg 2. So this one will be representing RE0 and then RB1. The output here from RE0 will go to the 7 segment. And then what you see here, array, we have array. This is in the form of hexadecimal. So you can see this one from 0 to 9. 0 to 9. So the size here not indicated, also settable. Okay, so this one is in form of hexadecimal. You can also put this in binary. So it's up to you, but make sure that the number is correct. So this one we call it a binary array. We introduce an array to hold the digital, to hold the 7 segment value for each of the character, starting from 0, 1, 2, 3, and then up to the final one, 9. And then after that, we create, you need to create a function. Okay, so this one will display any value on the keypad, any value according to the array. Okay, so what does the code contain inside this function? So basically, the name of this function is this one. Okay, S71 display BCD underscore. And then there are parameter. There is a parameter. So the parameter here is another variable. We call it BCD_num. So the type here is char, positive number char. So basically, when the program call this function, it need to include the variable value Okay, so that when call, when execute, the code here know what value to display. Okay, so you can see here when you give certain value, basically now will be transferred here. Okay, let's say you call it, you give it, let's say 1. So 1 will be here. So what is the value of 1? 0, 1. So number 1. Okay, so number 1 will be transmit through port G and then wait for another 30 microsecond. So the rest will be the setting. We are using two port B as input and then port D as output. And then also port E to control the 7 segments. So there are actually 3 ports. Okay, make sure that you configure them correctly. Only port D need to be configured as input. The rest should be output. And then this one, okay. So this one after this maybe you can play around. But for right now, we are only enabling 7 segment, the first 7 segment only. Okay, there are 2 7 segments, so we are enabling the first one. And then introduce a variable char. The type is char. The positive value. And then we put the initial value of up equal to set. We set the initial value equal to 0. We set it, the initial value to 0, and then go for continuous looping. And then this one will read input from switch 1. Input from switch 1. So switch 1 must be active low. Switch 1 must be active low. So if the condition is true, so basically, okay, so you can see here, okay, the program will call this function, okay, which is here. Okay, so it need to include number here up. So up starting because of initial start, up will be 0. Okay, so 0, this means that the 7 segment will display 0. And then wait for 1 second and then increase. And then check. If the value is up equal to 10, you reset the value to 0. If not, repeat the whole. But need to monitor the status of switch 1. If the switch is not true, so don't do anything. Okay? Because the condition is not true. Okay? Either for this one or this one. So that's it. Okay, so we go to the program. Make sure that you create correct program setting, project setting. So before you do, check first. The debug tool must be PixSimLab, and then the compiler must be XC8, and then the microcontroller of choice must be PIC16F8778. So this one, you need to check first. Okay, so, and then if everything is correct, you can start by create main.c. Okay. But for my example, already created, so I just add the program. So you can see here. And then check. Make sure that the clock is 20 megahertz. If not stated, not stated, use it 20 megahertz. Always check the clock frequency. Okay, so right now we are using at 20 megahertz. So make sure that here also must be 20 megahertz. And then this one just the same. You just copy from the module. Okay, so nothing see except for this one. So you can see here. Since we are using port E, so you need to disable the analog pin from port E, because port E is actually producing more than one function. Okay, so we want port E just to behave as input and output, digital input and output. Okay, if you are not doing this, so the program, the microcontroller will be confused. Okay, so make sure that you turn off first digital analog pin for port E. And then the rest would be the same. Okay, so if nothing, if you are confident with your program, you can start by building the program and then check. This one must be success. The status here must be success. Okay, success. And then, okay, one success. So you can see here, no peak sim. Okay, no peak sim tab. So you can go. This happen because you only when you first start. Okay, after that, the pin, the tab will be available, provided that the connection is successful. Okay, then after that you can see if no problem, peak sim tab will appear here. Okay, peak sim. So run target, off target. So you can go to spare part. Okay, you can start building. This one is not the correct one. Go to configuration. Okay, this one. Before you set, before you run the program, this one I forget to mention. Make sure that the properties is correct. The properties is correct. Set A, the data pin from A connected to RT0 and so on up to G. Okay, the order. Okay, must follow this order. Otherwise, the character will not be correct one. And then for point, we are not using point. Better set it as not connect. And then this one for selection, 7 selection. Okay, only 2 pin, RE0 and REB1. The rest you leave it as it is. And then 85, make sure that 85. And okay, so the program is still running, connecting. So you can see 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 0. Okay, sorry, 0. So you can see here why, okay, delay 1000 milliseconds. So that's why, okay, if I press this quickly, nothing will happen. Okay, see, okay, because of the delay. Okay, 1 second. If I press anything lower than between the period, 1 second, nothing will happen. Okay, so see what happened when I pressing and then I try to press again. Okay, so nothing happened. Okay, after that, after 1 second, the value will be updated. So that one we conclude for exercise number 1. So we move on to the second exercise. Second exercise, you can see from figure 3.8. So the question is, write the following sample program to read the key, press and display its number on the 7 segment. For example, if key number 5 is pressed, the digit number 5 will be displayed on the 7 segment here. Okay, so okay, several assumptions need to be considered. When A, B, C, or D, this one, not this one. Here, the key A, B, C, D, when the user, when you press key A, B, C, D, the 7 segment will display the same input. So the 7 segment, if you press A, then A will be appear here. If you press D, D will be shown here. Okay, so according to the value of the input, if you press 4, then 4 will be shown here. And then you go for program code. Okay, so this is important. Okay, so this one will be the row, this one will be the column. Okay, so make sure the arrangement is that the first 4 bits from port B must be set as output, and then the remaining 4 bits must be set as input. Okay, we are using the same port. You can also use different port, but make sure the setting here and here is correct. Okay, the first 4 bits must be output, and then the other 4 bits must be set as input. Okay, input must be set to column, output must be set to row. And then from here, okay, so this is a scanning function. Okay, so you need to include this one in your program also, other than this one. Okay, this one function to display character. So you need also to include this one, okay, in your program. Just like the previous one, okay, you need to include this function in your program. You need to copy. Yeah. So we go for the first function here. This one will do the scanning process. We try to identify which character, which key being pressed. So the name of this function, we call it read keypad. Okay. So the type is char, positive number. Okay. And then the scanning, okay. Introduce a variable, okay, with initial value 0. The type is char, unsigned, positive number. So you can see here, this is the scanning, like I said, like you see in the video previously. So start by enabling row 1. Okay, so the rest turn off. Okay, so the program will start by enabling row 1, and then after that it will check, okay, check connection for each column connected to that particular row. Okay, so the program start here, row 1, and then it will check column 1, column 2, column 3, and then column 4. Only here. Okay, if row 2, then only this 4. Okay, if row 4, then the last one. Any pin, any switch that is connected to that particular row only. Okay, it will detect that. So start by enabling the first row. The rest you disable, and then you check. Okay, you check. If the condition is true, it will return the index number. Okay, not the value. Okay, so you can see here y1, y2, y3, y4, because here, okay, 1, 2, 3, 4. Okay, not A. The return number is not A. 4, 5, 6, 7, 8. Okay, 9, 10, 11, 12, 13, 14, 15, 16. Okay, the return number is numerical. So you can see here throughout 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and then the last one 16. Okay. So it is not actually returning the character, but it is actually returning the index number. Okay. So similar process, repeat per row. So starting for the first row, and then check for first, second, third, and then fourth column, and then disable the first row, and then enable the second row. You do the same thing. Check for the same column. Okay, the same column, but at a different row. So if condition true, then return the index number. Okay, so do the same thing. And then this one, same like previous one, we are connecting to 2 segments, so need to include this one. So you need to include this one. So you need to include this one, and then this one. This one would be the same as the previous exercise. This one you need to display the number on the 7 segment only. Okay. So this one same like the previous one, and then after that you need to declare the array pattern here, starting from 0 to 9, and then after that you go to the main subroutine. You go to the main subroutine. You need to set which one is the output, which one is the input. Okay, so from here, so you can see, okay, so this one 0, okay, why 0? Because B0 to B3 we set it as output, and then F, why F? Because F is actually 1 1 1 1. Okay, so if you don't know, you can always check, okay, using this calculator. Okay, hexadecimal, the value is hexadecimal. So F actually 1 1 1 1 1. So the writing here is F0, so F0. So same like this one. Okay, so this one first 4 bit output, the last 4 bit input. This one row, this one column. So you can also write in notation, in binary notation, also settable, okay, but make sure that it is correct. So 0 be 1 1 1 1 1, and then 0 0 0, and also 0. Okay, so you can also use that value, just as long as it is correct. So this one, port D as output. So trace E, okay, everything set as output. Okay, and then disable. Since we are using port E, disable the analog pin. And then see, you can see here, okay, right now the program is enabling the second 7 segment. Okay, the first one disable, and then the other one you enable. So the program go to continue looping. It will start by calling this read keypad. Okay, calling this keypad. If the condition from this function is true, the value will be transferred to this variable char kp6, sign char. And then if the value is greater than 0, so means that the index number more than 0, so only positive number, only then the value is true. So it will start by calling another function. This one will display. Okay, so you can see right now. Okay, there's no initial value. Okay, why? Because the value depend on the input by the keypad. If the user press character key, character 3, so 3 will be transferred here, and then 3 is greater than 0. So go call this function. The index number here is 3. So the number is, okay, the number must be 3. And so on. So only greater than 0. Greater than 0. So, okay, that's it. So do you have any question? If you don't have any question, we go to the fixing side. Okay, so this is the setting. Okay, this one, similar like the previous one. Setting here, except for this one. Properties here, you go to the properties. Make sure, okay, the row start first from B0 to B3, and then the remaining 4 bit, you set it to connect to port B4 to B7. The pull type must be pull up. And then the type, show me here, 4 by 4. Okay, so that's it. And then go to the program side. Okay, create a program. Okay, this one already included. Okay, before you do anything, make sure pick same lab, XC8, and then this one. The microcontroller of choice, PIC 69F778. The clock frequency is at 20 MHz. Always check at what value you are writing. Okay, make sure that the program value and the program and the actual hardware is similar. If you're using 8 MHz, you need to write down 8 MHz. Otherwise, okay, change it. Okay, so the rest will be the same. The rest will be the same. So it's nothing. Nothing. Okay, you proceed to building the program, and then okay, build success. Build success. Okay, go for debug. Okay, fixing already shown here, so you just wait. If correct, then the tab will be active. Okay, we success, and then you can see. Okay, so pick sim. Okay, so hot target, run target, so you can see from here. Okay, nothing happened because not pressed yet. 1, 2, 3. So why seg 1? That one we will see later. A, B, 9, 0. This one, nothing happened because you are not doing anything to indicate that character. 7. Okay. So why the first one? So this one related to this one. Okay. So right now the code is enabling the first segment. Okay, so you can change it. Make sure that you stop the curve first, and then you repeat. Start repeat by building. Any changes made to the program, you need to rebuild, and then after that you debug. Will be success, and then go to debug. Okay, be a success, pick sim. Okay, so okay, see. Previously, the first segment, and then after that, when we make changes, okay, the character will be shown here. 3, C, 9, 0, 8, and so on. Okay, I think that one will conclude the exercise. Okay, you try to do it. Try to do the exercise first before you go for the design question. So we look at the design question. Okay, similar like the previous one, you have 3 parameters here. Write a C language program to read the keypad, key press, and perform the following tasks. There are 3 tasks here that you need to follow. Let's say if you, the first task, if you press the odd number, display the value on the segment. If you press 3, 3 will be shown on the display. If you press 5, 5 will be shown here. If you press 9, 7, same character. And then if the even number is pressed, 2, 4, 8, and so on, the value turn off all the 7 segment on the 7 segment display, all the value of the character. So if you press even, okay, nothing will happen, it will be turned off. And then if other key is pressed, other than odd and even, okay, so this means that can be this one, A, B, C, D, or this one, or this one. Turn on the segment and display come up from 0 to 9. Okay, so this means that when you press, let's say you press D, the segment will be on and will start by counting up from 0 to 9. Okay, so that one, that's it. So the format, similar like the previous one, front page must be included with 2 respective member, and then introduction, briefing on the design question only, and not the topic. Okay, the whole topic, just a design question only, and then your methodology must be include schematic and also flowchart. So make sure the schematic must be very complete, very detailed and complete. And then result and discussion. Okay, write down discussion. The result must be must have a demo video, 3 minutes. We prefer 3-minute duration. Do not put more than 3 minutes. Only show the output only. Okay, and make sure that you narrate the whole video. You need to explain what is the output, how does the output perform, and then you need to show what happens if you click button, click switch button, and so on. Okay, and then you need to narrate on the programming aspect and also the hardware on the devices on the microcontroller system. So when you do this, when you have created the video, make sure that you upload. Okay. At the same time, make sure that the link also attached. You need to include in your report. Okay. Put down the list. Put down the link on your report. Okay. And then conclusion, write conclusion based on the design question. And then the last one, appendix, must contain the copy of your NP program. Okay, so completed report, you need to go to this link. Okay, so you need to register, and then at the same time, you load your report in PDF version, and then also included the link for your video. Okay, the link here, it can be in YouTube, it can be in your Google Drive, but you need to make sure that we can access the video. Okay, so submission next week on the 29th. 29th would be on Friday. Okay, so this one, after that, the Raya week. Okay, so this week also, before you go celebrating, I think on Wednesday, okay, your quiz. Okay, make sure that you inform your friend. Okay, only G2, only group G2. Inform your friend G2 group only that your quiz will be conducted on Wednesday. Okay, if you have any problem, you cannot commit on that particular day, inform me early as possible. Okay, so that we can do something. If you do this last minute, it would be impossible. So I think that's it. That's it. That one we conclude the briefing for lab module 3. You have any question you want to ask? Ada soalan nak tanya? You have any question you want to ask? Ada soalan? Ada soalan? Semua boleh buat. Okay, so if no question, I think we stop here. Thank you very much for your attention. So make sure you follow the deadline and make sure that you submit your report today for lab 2. Okay, so that's it. Thank you, Miss. Thank you very much. Assalamualaikum.